In this video, I'll be talking about metallic bonding. So in the previous videos, I talked about ionic bonding and covalent bonding, and I related it to electronegativity. When you're talking about metallic bonding, you can relate it to electronegativity. So metallic bonding is pretty different. You have to consider it in a different way than what you would do for ionic or covalent bond. A metallic bond is simply a bond between a metal cation, so metal cation, and loose electrons that move throughout the metal. So they're just called free electrons. So you don't really have like a combination between two atoms or something like that. It's just how a metal works. And there's a diagram called the sea of electrons that really helps you understand how metallic bond works. And I'll try to draw it. So we have our metals that are actually very close together. I'll just draw the circle first. But they don't. I'm sorry, I can't draw. So we have very close together cations, and in between those cations you will have your electrons. I'll just draw it as a red dot. So this is an electron, and this is our metal cation. So it's called the sea of electrons model because those electrons can actually move freely whatever, like just move there and move there. And you may be wondering, how does this help me understand a metallic bond? So when you think of a metal, just let's say think of a spoon. You can bend the spoon if you apply the right force. And just think as actually, let me draw it really quickly. So let's say you have something like this. Again, there's no overlapping, but I cannot draw. Or whatever. So you have a spoon, and then that's a very horrible spoon, I'm sorry. You have the electrons flowing everywhere. So when you heat a spoon, when you apply the right force, you can actually move these cations, and there's no force that will move it back. So back to our sea of electrons. If you move this, like let's say you apply a force like that, there's no electrostatic force or sharing of electrons that will want to like move it back. It will simply deform. So let's say you hit that very hard, then this cation will move down, and it will just move like that. So then you will still have three, but you just deformed it. So that's what happens when you, let's say, just bend a spoon. You're actually deforming it, and it stays like that. It doesn't go back unless you apply a force again, just because there's no force that's keeping it like actually together and will return it back. It's just cations that are very strongly pushed together with electrons, but with the right force you can bend it. And that actually explains why they can boil, why they can conduct electricity pretty good. It just goes through, and all of them will start kind of vibrating, or when they're boiling, so everything will vibrate, and because they're so close together, it's easier to just heat than something like a rock. You can't really heat a rock. And using the same model, let me erase this. when you think of something like an ionic compound, like a mineral or whatever, when something is ionic, you have something like this. So it's positive, negative, and negative, positive, negative, positive. That works. So let's say you hit this part in an ionic compound. It will push it down, and when it pushes it down, what happens is this. Negative, positive. You see there's two positives and two negatives, and that will break apart. Because it's only electrostatic force, that repulsion will just make it two separate things. So then you'll have something like this. Positive, distinct negative there. Positive, negative, and then this different thing here. So you would have, instead of, we have one compound here, and then we have two compounds. And that's what happens when you hit like a rock to the floor. It breaks apart because those electrostatic attractions will just repel each other when they move down. When you do that to a metallic element, a metallic bond, they will just bend. Again, there is no attraction or repulsion between the ions, so pretty much nothing will occur. There is attraction between the little loose electrons that just keeps it together, but there's no really like electrostatic force between it. Oh, well, that's it for metallic bonds. If you found the video helpful, like it and share it with your friends.